was 1978. We were starting our senior year in high school, and the school decided to buy a brand new Commodore Pet 2001 series personal computer, the first computer ever to exist at the high school. And it turned out that it sat in the classroom where math was taught, and only about a half dozen folks wanted to ever use that computer. As my brother said, it was nice for the school to buy half a dozen of us a computer. And our little group decided we were going to write game programs, and that's largely what we did. Every sort of noon break, except we had school in those years from 7 a.m. to noon because of some financial issues at the school. So our mid-morning break was often spent programming, and sometimes we stayed after school and did some programming as well. And at the end of that year, when we were going to graduate, I seem to remember that I told people, we need to keep these programs that we've written, and I want everybody to put their programs on a tape. And I'm going to keep that tape so we don't lose the programs. And this is the tape that we recorded at the end of the year. And I've now had this tape for 39 years. And I have never been able to recover those programs. I've never owned a Commodore Pet computer, nor do I really want to own one anymore. However, they make emulators for all the Commodore computers, so you don't need to buy a computer anymore. You can run the programs on an emulator. But the real trick is how to get the programs off of that cassette tape and get them into an emulator. Now I should mention that in addition to the tape, I also have this lovely piece of paper on which we wrote the programs which we recorded. The first one is Microchess. That was not a game we wrote. That was a Commodore program that must have come with the computer, but I did save it on this tape. But the rest of these programs we all wrote. So one of the goals when I recover these programs is to try to figure out who wrote the programs, because I can no longer remember which ones I wrote. But if memory serves me right, many of us, or all of us I hope, put our names in a comment at the beginning of the basic program. So if I can recover the programs, I hopefully can figure out who wrote it. So the quick look down the list here, let's see. A Little Duck, Kermit Tanks, Nothing Much, Vegas Craps, The Wheel, Parabola, Cut-Ups, Battlestar, Commie, Poet, Raceway, Scrambler, Block, Blackjack, Pong, Blackjack 2, Galaxy Games, Alpha, Kaleidoscope, Eyewinder, Triangle Display, Circular Square, Decimal, Pythagorean, Blockade, Clock, Toilet, Trace, PD22 Composer, and then a bunch of things that sound like songs, because as I remember, this Pet did not have a speaker, but it did have a piezoelectric buzzer, and we figured out how to make it do songs by buzzing the buzzer. Stare, Soared to Heaven, Yesterday, Strawberry Fields Forever, Goodbye Yellow Brick Road, Eleanor Rigby, 64, Penny Lane, Hey Jude, and Hawaii 5-0. Now, I should mention that I took reasonable care of this tape through the years. However, I do notice that on the other side of the tape, sometime in college, I did record Supertramp. And I'm wondering now whether all the programs fit on the one side or whether we may have lost some by recording Supertramp on the other side. We will find out. Now, Commodore had an interesting way of storing their programs on cassette tape. You would think that the cassette player that was built into that Commodore Pet was just a simple audio cassette player, but this was not the case. Commodore bought the cassette decks from companies like Sanyo, went inside, immediately took the electronics board, which did all the audio, and promptly threw it away. They then completely replaced the electronics with their own circuitry. And here's a diagram of one version of the circuit board they put in. Essentially, what happened here was they didn't want audio in and audio out. They wanted to put in a digital square wave, and when they played it back, retrieve a digital square wave. And that's what this circuitry did. It had a very simple connector on it here with very few pins. Basically, there's a couple grounds. There's a 5-volt logic supply, we'll say 5 to 9 volt voltage for the motor of the cassette deck, which is regulated internal to the motor. And then there's one pin that tells you if a key is depressed on the cassette deck. Doesn't say which key, any key that's pressed. And then there is a single line for read and a single line for write. Those two lines are digital lines, basically TTL 5-volt reference signals going in and coming out. And you would put in the square wave and you play it back and you get out a square wave. And you can kind of see the circuitry they did that with involved several stages of op amps and filtering. And so that cassette deck, I have one of here. This is not from a Commodore Pet. This particular cassette deck was from a Commodore 64. And after some research, I found out that the cassette deck was essentially completely compatible between the Commodore Pet, the VIC-20, and the Commodore 64. So I promptly went on to eBay, and they advertised this one for a Commodore 64. It was $35 including shipping, and I promptly bought it, and it looks almost like new. It looked like a good buy. And so now we're going to try to play the tape and see what we get off of it. All right, step one here is I've hooked up the read output onto a old digital logic probe, and it doesn't tell you too much, but it does tell you whether your signal's high or low, and if you get something like a square wave, both lights will light up. And so we'll just play the tape here a little bit from the beginning and see what happens. So turn on the power supply and hit play. And right now I started off, we're at a low signal here, and if you can see that, and after there's a leader to the tape. Oh, and now we get some both lights are lit, indicating potentially something like a square wave, and down it goes. So that's not going to tell us very much. So I think we need to progress on to the next step. Okay, next step. We have ourselves an oscilloscope hooked up to that read output line, the same as we had the digital logic probe hooked up. So let's hit play and see what we've got. So again, there's a leader on the tape here. All right. Oh, there we go. We've got what looks like pretty much a square wave. Pretty constant. Let's see what happens. Oh, now we've got some different stuff. Here we're back to a square wave. Now we've got what looks like potentially, and I know what I I'll explain later, but what we're actually seeing here are square waves, but they're square waves of different durations. There's 3 different period square waves, and you're seeing basically the shadows. We're triggering on an edge, of course, and so we're just seeing the different lengths there sort of overlapping each other on the screen. So very briefly here, I'll try to explain what we're actually seeing here on the scope. So now what I've connected to the read pin off the cassette deck is a simple Arduino Uno. It's got a processor running at 16 megahertz. And I'm going to use this to essentially sample the signal and try to extract the square waves. Now, as I may have already explained before this, or I will afterwards, there are 3 lengths of square waves: a short square wave, a medium square wave, and a long period square wave. And this is just fast enough to try to sample the square waves, measure the time between trailing edges, figure out whether it's short, medium, or long, and output that over the serial port, which is really kind of a virtual serial port over the USB connection here. So what I'm going to show next is we're going to play the tape, and we're going to look at the serial monitor and see what it's putting out. So again, what's going to show up on the serial monitor is I'm going to output a single letter S for a short square wave, a single letter M for a medium, and a single letter L for a long square wave. So we'll see some sequences of S, M, and L's, which will indicate the square waves coming off the read pin of the cassette deck. All right, here is the PET program that I have written, which is going to try to take the square waves from the tape and get it into some usable format. So what this program does, it's quite short. It basically sets up pin 7 on the Arduino to read in data as a digital in. It sets the baud rate as high as possible on the serial port, 250,000 baud. Then just has the normal sort of loop that you write in an Arduino program. It goes off and basically goes in a loop looking for a falling edge, so looking for the logic signal to go from a 1 to a 0. When it sees that, it samples the system timer, which I'm reading it in microseconds. And on this little Arduino, the finest resolution I can get is 4 microseconds. And then basically it saves away that time value, goes around the loop until it finds the next falling edge. When it finds the next falling edge, it measures the difference between the 2 falling edges, and then it determines whether it's a short period square wave, a medium period square wave, or a long period square wave. Or if it's none of those, it's something I call extra long. It then outputs on the serial port a single character, either a letter S, an M, or an L for short, medium, long, or an X if it's extra long. That printing that out to the serial port takes 40 microseconds, but that's fine. I can withstand that time. So that's all it does. Looks at trailing edges, determines what length the square wave, outputs it on the serial port. So if I bring up the serial port monitor here, let me do that. And I had the tape playing. Let me tell it to scroll here again. Okay, so here's the data rolling by. So let me stop it scrolling and let's look. And indeed, we can see here that we have S's and M's, and there's an L or two floating around as well. And I'll explain why that makes perfect sense when we figure out the next step, how to take that and decode it. Now I did, in order to get this into a file, all I did was redirect the serial port to a file. And here's that file. This is just a sampling of what's in there. It turns out that at the beginning of each program, they put out a lot of short square waves that the Commodore computer could use to basically set its, the tape player might record and play back at a slightly different frequency, or different tape decks might be a slightly different motor speed. So they put out a lot of square waves that you can read in and try to get an idea, calibrated essentially, to what a short square wave is. And then in the program, it first it stores a header which has the name of the program twice. It stores the header twice, and that's what this glob is. And then there's a little gap before it puts out the actual program. And then here's the actual program, and that is written twice as well. So this is fabulous. All I did was play the tape, the entire side of the tape. There was about 40 minutes of recording on it, and captured this in a file. And now I'm done needing to run the tape deck at all. I can go write a C++ program and post-process this data and try to recover the programs.